All right, we're going to talk about chapter 6.2, which is applying applying the properties of rational exponents from algebra 2. First thing we want to do is make sure you remember your exponent rules. So if you don't have those memorized or you don't have your notes in front of you, make sure you're watching these quick. Remember, a to the m times a to the n, our bases are the same. Our rule is a to the m plus n. A to the m divided by a to the n, that means that our rule is a to the m minus n. A to the m times n, power to a power, a to the m times m. A times b to the m is really a to the m times b to the m. And a divided by b to the m is a to the m divided by b to the m. I know those words are kind of confusing, but make sure you guys have those down because we're going into more difficult things. So we need to find the products of these. So really remember what we do is we multiply the inside times the insides and the outsides times the outsides, and then we simplify from there if we can. So if I look at that first example, and I'm going to do a couple examples, and I'm just going to put up the answers for you so you can check your solution, see how you did. So the first one here, outside times outside, is 8 times, and the inside times the inside is going to be square root of 15. Now, can I simplify that any further? Well, the only thing that multiplies to 15 is 3 and 2, or 3 and 5, sorry. So I can't simplify that any further. That's as far as we can go. Now, if we look over at number 2, I'm going to make my prime factor tree first, because really what this is, it's the cube root of 32 times 16. So I'm going to make a prime factor tree to see if I can cancel anything out. So I'm going to get 2 and 16, 2 and 8, 2 and 4, and 2 and 2. I'm going to do the same thing for 16, so I use that, use that, use that, use that. So 16 is 8 and 4, or sorry, 8 and 4, 8 and 2, 2 and 4, and 2 and 2 again. Now I have the third root, so I'm going to go look for groups of 3, and notice they all come out. So really I have 3 groups of 3, which is 8. And there's our solution there. All right, I'm going to do a harder problem here. Number 4 looks pretty difficult. So let's look at that guy. So just like we did in the other ones, I'm going to multiply outside times outside. So I really get 20x squared times the square root. Now I'm going to combine, well, really I'm just going to do 8xy times 4x squared y cubed. Now this one you could combine them. You could do your factor tree. I like to do the factor tree. So I'm going to do the factor tree of the 8 is 2 and 4, 2 and 2, and 4 is 2 and 2. Cancel there, so cancel there. So you look, we have a 2, we have a 2, so I can pull those out. So right now, I know what I can pull out. I already have the 20x squared outside, but now I'm going to also pull out a 4 because I have 2 times 2. Let's see if we can pull out anything else. Well, I'm going to look at my x's here. I have 1x here, and I have 2 x's here. So I can pull out another x from that piece there, because I'm going to really get x times x, which means I can pull out a pair. So I'm going to pull out that x. And this 3 here, or these y's come y, y, y. But then I have one more y over here. So I have one group of y's here. I have another group of y's here. So really I can pull out 2 y's. And I know it's getting sloppy here. I apologize. But so what we have here, now what we have left inside is, well, we have this 2 left, we have that x left, and that's it. So really it's a square root of 2x. Last but not least, let's put all our pieces together. We get 80x cubed y squared times the square root of 2x. All right, that one was a little bit difficult. Let me try to do one more for you here before we go on to anything else. Let's do a less difficult one. I'll do number 5 for you. So again, we're going to do our outside is just going to stay the 4 because that's the only thing on the outside. And then the cube root, 14 times 28. And one more time, before I even do anything through that, I'm going to split this up to 2 times 7. This is going to be 2 times 14. And this is going to be 2 times 7. Well, if you look, I have one group of 3 2's. So really what comes out is a 2. So my outside is actually going to become 8 times the cube root of, and what's left inside is 7 times 7, so 49. All right, I'm going to erase these and I'm going to show you, put up the answers for you for the last, so number 3, number 6, number 8, and number 7, I'll put up the answers for you. All right, here are the solutions I got, and I showed work. I know it's small. I left the answers up for the other pieces. Let me erase those so you can see which ones I did. So now if it was me, I'd make sure this is in full screen so you can see each piece of it. Let me know if you guys have questions. All right, let's try some of these guys. Same kind of things that we've been doing, so I'm not really going to do these. We did them in the last section, 6.1. So if you guys don't understand these, go rewatch that video. Now, let's try these problems where it gets a little bit trickier because we're working with more difficult numbers. So, remember, when we do 2 to the 1/4 to the 2/3 power, really what we're doing is we're multiplying those things, so it becomes 2 to the 1/4 times 2/3, which means we multiply across. This becomes 2 to the 2/12, and we need to simplify that because we can, and it's, what we need to look for is what can I take out of the top and the bottom. Well, this becomes 2 to the 1/6 power. Fully simplified version. Cancel out all the things that we can get rid of. All right, let's do number 19 here for you. So remember, number 19, what we need to do is we have division, so we need to subtract. So we need to do y to the 5/7 minus the 3/14. But if we look there, well, we need to get common denominators. So my 5/7, I'm actually going to change that to 10/14, so which means we do 10, now when we subtract, remember we do numerator subtract there, so we get y to the 7/14, which again we can simplify that to simply be y to the 1/2 power. Now you could rewrite that as the square root of y as well. Number 17 and number 20, I'm going to skip those and come back to them. I'm going to have you guys do those, but I'm going to do number 18. Remember, when we're multiplying those, we add the exponents, so we get 1/2 plus 3/10, which means I need to change that 1/2 to 5/10, and when we do now is we just add those up, so we really get y to the 8/10, and last again, we need to simplify that, divide each top and bottom by 2, so we're really going to get y to the 4/5 power. All right, let's do one more for you here. I'll do number 21 for you quick. So number 21, remember we need to put that half power through to each piece, so really this becomes 16 to the 1/2 times x to the 14th to the 1/2. Now really 16 to the 1/2 is the square root of 16, so that means that is 4, and x, when we have exponents to exponents, remember we multiply. 14 times 1/2 is 7. There's our fully simplified version there. I'm going to have you guys do number 17 and number 20, and I'll put the answers up here in a second. All right, why don't you guys check your answers? And I did mean to do number 17 and 20. I think I said 16 and 20. All right, here are some more problems I want you guys to try on your own. I'm not going to do those ones for you, so if you did print out the notes, I apologize. I want you to try these ones on your own. Let me know if you have questions on those. But now let's try, we need to go and we need to rationalize our denominator. What that means is I need to get rid of the square root or the root, the radical in the denominator. Well, first thing I can do is I can remember my rules of square roots. I can make this be the same thing as, well, it is the same thing as 125 divided by 5. So the square root of that is the same thing as the square root of 125 divided by the square root of 5. Well, I know what the square root of 125, or sorry, I know what 125 divided by 5 is. Well, that's really just the square root of 25. And we all know what the square root of 25 is. That would be 5. All right, so I'm going to do the same thing with this next problem down here. Is I'm going to change this to be one big square root of 32x squared y over 8y. And the reason I'm going to do that is because I can simplify piece by piece again. So piece by piece again, let's do that one in blue so we keep our colors the same as we did up there. So piece by piece again, 32 divided by 8, well that is 4. There is no x's, so x squared stays the same, and we have y over y, so they cancel each other out. So really right now we have the square root of 4x squared. And again, this is kind of the same thing as, or it's not even kind of, it is the exact same thing as writing this as 4 x squared to the 1/2 power. So really we're going to take the square root of 4 first, which is 4. We're going to take the square root of x squared, which is x. So this piece becomes, sorry, the square root of 4 isn't 4, it's square root of 4 is 2. This becomes 2x is our fully simplified version of that. All right, I want you to try these two on your own. I'll give you a hint that that last one, it will be a trick question that I will get to the finish. I'll get you to a certain point, and then I'll finish it off at the end there. So try those on your own. All right, so here's the furthest you could go. The top one, that's as far as you can go. The second one there, though, you can go further than that. And what I mean by that is you need to get rid of that radical that's in the denominator. You cannot have a radical, an irrational number in the denominator. So what I need to do is I need to look at what do I need to multiply the square root of 3 by to make it so there's not a radical there anymore. So really, let's see, what do I need to multiply 3 by inside to make it so it's a perfect square so I can get rid of it? Well, we know if we do the square root of 3 times the square root of 3, so if I do the square root of 3 times the square root of 3 on the bottom, that means that our denominator would then end up being the square root of 9, which that's what we'd want because we want to get rid of that, which would make it a 3 on the bottom, right? But now if I just multiply by 1 over the square root of 3, I'm changing this problem. I need to multiply it by a special form of 1 to make it so the problem doesn't change, but it is going to get rid of that denominator. How I do that is I multiply by the square root of 3 over the square root of 3. What's the square root of 3 divided by the square root of 3? It's 1. So I'm multiplying by the special form of 1. Now what I do is I multiply our insides times each other. So 14 times 3, which really means the square root of 52x. Sorry, do my math correctly, that would be 42x. Square root of 42x. Now I know I can't simplify that part any further, but what I can do is I can simplify my denominator. So my final answer to this problem is going to be the square root of 42x divided by 3. Notice there's no radical in the denominator, and we can't do any more square rooting anywhere else. All right, so let's try some of these problems. Go on the opposite way of splitting these up before we do it. Now, we already did this first example, but I'll do it quickly. The first thing we got to do is, well, we can do 125 divided by 5. Really, this becomes the square root of 25, which we know is 5. Done. First step in that second problem is I'm going to split it up to the square root of 15 divided by the square root of 2. Reason is I can't simplify the square root, I can't do 15 divided by 2 and get a whole number. So now what I'm going to do is I'm going to get rid of that square root on the bottom, that's a square root in the denominator, and I'm going to get the square root of 30, and that square root cancels out over 2. Now I do need to check, can I simplify the square root of 30 anymore? Well, let's think about this. We have 2 times 15, so 15 can make it 3 and 5, so I can't simplify that any further. So what I said there is I could do 2 times 15, 3 and 5. Nothing can get simplified any further, so there's our fully simplified version. All right, let's try another problem here. So again, we can't do 12 divided by 5, so really this is going to be the cube root of 12 divided by the cube root of 5. Now this one's going to be a little bit trickier than what we did before, because really what we need to do is we need to make it so, and what we were doing up here is we were making it so that we had 2 squared. Notice that these two pieces right here are 2 squared. So when we have square root, we want to make it so they're squared. When we have the cube root, well, we want to make it so it's cubed. So I need to make it so it's 5 cubed. What do I multiply 5 by to get to 5 cubed? Well, I multiply it by 5 squared. So we'll do the cube root of 5 squared, and on the inside, we'll do the cube root of 5 squared, but I know what 5 squared is. It's 25. We're going to multiply those pieces through. All right, so now the 5 times 5 squared is really 5 cubed, which that means that our piece cancels out like we want it to. So it becomes the cube root of 5 cubed. And then we do the cube root of, well, 25 times 12 is 300. And we can't simplify that any further. I can look over here At my cube root of 12 and my cube root of 25, before I put them together, this becomes 2 and times 2 times 3, and this is 5 times 5. They don't have anything that'll cancel out with cubes, so it stays the same, but I can simplify my last piece there to make this the cube root of 300 divided by 5. That is what our fully simplified version would look like. All right, so now let's think, what do I need to multiply? Again, the cube root of 4 divided by the cube root of 5. I need to make it so my denominator, I have 5 cubed to cancel out that cubed root. So just like we did before, we're going to multiply by 5 squared. And on top, I'm just going to make it the cube root, don't forget our cube root in there, of 25. So which makes this end up being 4 times 25, the cube root of 100, divided by 5. Fully simplified version there. All right, now we look at this next piece. This is going to get another trickier part. We have the 5th root. So again, the numbers we need to be able to cancel out are 2 to the 5th. Well, if I only have 1 2 already, how many more 2's do I need? To get to the 5th root, I need to get 4 more of those. So 2 to the 4th. So we're going to take the 5th root, and 2 to the 4th is 16. Now we multiply our insides, we'll get 2 to the 5th, which cancels out to be 2 in our denominator. Now we don't have a radical with our 8, so really it just becomes 8 times the 5th root of 16 on our top. And there's our fully simplified version. All right, the last one's pretty tricky. I want you guys to try that one on your own, and then I'll put the answers up there the answer up there in 1 second for it. All right, so I hope you worked on this problem for a little bit, or if you got it right away, awesome. Now the way I did it is I wanted to simplify what I have first. So number one, what I did is I looked at the outside. I have 2 divided by 4. Well, that's 1/2. So I got rid of that first. Then I looked inside of my cubed root there on the top, and I have an 8. And I know I can take the cube root of 8. And the cube root of 8 is 2. So that's what my number 2 there, my blue part is. Then if you look over at my red part, my number 3, again I have 2 over 2, so those cancel out. Now I need to bring that down and simplify it. So I have the cube root of y over the cube root of 7x squared. So in that green part on that bottom there, I looked and I said, well, what do I need to multiply 7x squared by to get to what I need, which is 7 cubed x cubed? So in the blue, I needed to multiply by 7 squared x. And that's what I did, and I multiplied across, and there's my final answer. All right, that's all for this video. Let me know if you guys have questions. Rewatch anything you need to watch.